Hi everyone, this is Mrs. Ludis. This lesson is called Hodgepodge. So it's got a bunch of topics that we couldn't really fit into like one singular topic, but are common topics that you can expect to see on the SAT. Okay, so the first one is about circles. Okay, so the equation of a circle looks like this. So let me write it down and then we'll break down what all of these mean. Okay, so it's x minus h squared plus y minus k squared equals r squared. Okay, so there's a couple of things here to label. All right, h is the x value of the center. And k is the y value of the center. Okay, we know in a circle all the points on the edge are equidistant from the center, so that's an important point to know. Okay, and then r is the radius. Okay, so you can see here in our equation, the radius is squared. Okay, so whatever's over, let's say it was a 64, the radius then would be 8. Okay, so let's just draw a picture and label some of these things. Okay, so here's my circle. Okay, my center here would be h comma k. All right, and then I can draw in this radius anywhere on the circle because we know they all will be the same. Okay, so I could draw it here, I could draw it here, wherever it may be. Okay, so here's an example of a problem that's pretty common on the SAT. Okay, so example 1, they give us an equation of a circle. Tells us it's the equation of a circle. Okay, if the circle is translated downward a units so that the circle is tangent to the x-axis, they give us this new equation. Okay, so basically here I have, the only difference between this new equation and the old equation is it has this a here. Okay, and it wants us to find the value of a. Okay, so a couple of things to break down here. First of all, tangent to the x-axis means it's going to touch the x-axis. Okay, so when I draw my circle, the outer edge of the circle will just touch the x-axis at one point. Okay, that's what tangent means. Okay, so let's look at our equation here. Going off of the equation that we just learned, okay, the center of the circle is going to be at positive 6, positive 3. Okay, it's minus 6, minus 3 in the equation. It's the opposite sign. Okay, and the radius is going to be 5. Since the equation is equal to 25, I square root it to get the radius, which is going to be 5. Okay, so let's just draw a rough sketch of what's going on here. Okay, I have my center at 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so here's my center. Now, it wants the radius to be 5. Right now, if this circle is going to be tangent to the x-axis, it would have a radius of 3. Okay, so basically what we need to do is we need to move the center up 2 units. Okay, so what this should say up here is y minus 5 squared. Okay, because I want this center to be at 6, 5 in order to have a radius of 5. All right, so basically this needs to be equal, this needs to be equal to 5. Okay, well, in order to do that, a needs to be 8, since 8 minus 3 is 5. Okay, so that's our a value. Okay, if I plug in 8 there, I get my radius of 5, which makes my circle tangent to the x-axis. Okay, so this is a grid in here, so I'm going to put my 8 at the end and then circle in the 8. All right, that's the only example that we're going to do with circles. Okay, we're going to move on to complex numbers. Okay, so a complex number is a number that involves an imaginary component. Okay, so the standard form of a complex number is a plus bi. Okay, a is the real part, bi would be the imaginary part. Okay, and if you remember, I is equal to the square root of -1. Okay, one important thing to remember with complex numbers is that I squared is equal to -1. Okay, and that's because if I were to square this up here, if I square a square root, the square root goes away and I just get -1. That's a really helpful thing to remember when dealing with complex numbers, which we're going to see here in a second. Okay, so for the first example, all we're going to do is simplify this expression. Oh, actually, before I go too far here, it does say use your calculator if possible. Okay, if I show you my calculator here, I have the Calculate 84 app on my iPad. The I is right above the decimal point. Okay, so it's really small. I know it's kind of hard to see here on screen share, but it's right above the decimal point. So some of these problems can be done really quickly on your calculator. Okay, and we'll try to do this first one on our calculator. Let's see if we can. Okay, oh, never mind. It says no calculators. Just kidding. But when we can on the calculator part, you will be able to use it. I'll show you an example. Like if I did 5i squared, that's going to be -5, since I know I squared is equal to -1. So if possible, it's a good idea to be able to use that. Okay, here of course we can't. Okay, so a couple things. I to the 4th, okay? I to the 4th is I squared squared, right? Okay, well I squared is -1 squared, which is +1. So this is just 1. 16 times 1 is 16, okay? Minus 8 times I squared. I know I squared is equal to -1 plus 4. All right, so 16, this becomes plus 8 plus 4 is 24 plus 4, which is 28. Okay, so just using what we know about complex numbers to evaluate an expression. Okay, same thing here. What is the sum of this complex number plus this complex number? Okay, so 6 plus 5i plus 8 plus 3i squared. All right, well, I squared is -1, so this becomes -3. 8 minus 3 is just 5. Okay, so we've got 6 plus 5i plus 5, and then I just combine my like terms. 6 plus 5 is 11 plus 5i, which is option A. Okay, so again, really important to remember that I squared is equal to -1. That will help you evaluate any complex number with any exponent. All right, next, these next two problems are going to deal with percent increase and percent decrease. Okay, so if I have something that has a percent that is increasing, one way that I can find the new amount is that the new amount is going to be whatever it was originally. Okay, so whatever the original cost or whatever it is, plus the percent increase times the original. Okay, so it's going up by, let's say, 8%. It would be 0.08 times the original price. Okay, we're adding that on because this is a percent increase. Okay, the percent decrease, you could probably guess, is going to be this exact same equation, except it's going to be the original minus the percent decrease times the original. Okay, another thing I want to throw in here is an equation that you probably learned in Algebra 1 and Algebra 2. 1 plus or minus r to the t. Or actually, no, that's something different. So just 1 plus or minus r. So this is the original, and this is 1 plus the increase. Okay, if it's an increase, then it would be plus. If it's a decrease, then it would be minus. So that's another thing to keep in mind. I'm going to use that one with example 5. Okay, so here's what we're looking at here, some percent increases. Okay, so Hongbo sold X cell phones in 2013. I'm going to start organizing my thoughts here. Okay, so in 2013, it sold X cell phones, however many that is. The number of cell phones he sold in 2014 was 120% greater than in 2013. Okay, so this is a percent increase, so I'm going to use this equation. All right, so in 2014, I'm going to do the original, which was X, okay, however many it was in 2013, plus the percent increase times the original. Okay, so if it's in 128%, that's 1.28. Notice how it's over 1. That means it's going up. Okay, 128% is pretty high. Okay, times what it was, which was X. Okay, so X plus 1.28X is 2.28X. Okay, so that's what it was in 2014. Then in 2015, it's 29% greater than in 2014. Okay, well, in 2014, it was 2.28x. So in 2015, it's going to be that original, and then it's going up by 29%. Okay, so I'm going to make that 1.29%. Okay, here's why. This is 1. Okay, so that would be it staying the same, and then went up by 29%. So 1.29. A big mistake that I see a lot is just making this 0.29, because that's a 29%, right? Okay, but it's 29% increase. So it's all of what it was plus 29% more. So 1.29. Okay, and that, I forgot my x here with the 2.28 from right here. So 2.28x times 1.29 is option D. They put it in the other order, but that's okay. Okay. Example 5 is similar, but I'm going to use that other equation for this one. Okay, so in 2014, the average price of 1 metric ton of oranges decreased, this is important, by 2.36% from January to February. Which of the following is closest to the price of 1 metric ton of oranges in January? Okay, so it's starting at 770, okay, right here. In February, it's 770, okay? So it increased to get there, which means it needed to be lower in January, okay? So, wait, hold on. It decreased from, no, sorry, it had to be higher in January. Okay, so if in February it's 770, these don't make sense. Okay, it has to be one of these two. And that's one thing you're going to want to do is try to get rid of any answers if you can. I'm already down to a 50-50 shot, even if I have no clue how to do this problem. Okay, because it had to be higher in January. So basically, in February, it started at 770. Okay, and then since it's a decrease, it is at 170, 770 times 1 minus 0.0236. Okay, that gives us, this is I'm assuming going to be a calculator problem here, so, okay, so I've got 770 times 1 minus 0.0236. Okay, so 751.83. Okay, so that's going to be, it's not exact, but that's going to be closest to C. Okay, D would be too far off there. Okay? All right, last topic that we're going to cover in the hodgepodge is polynomials and zeros. Okay, so if a polynomial has factors x minus a and x minus b, okay, then it has zeros. Okay, zeros, there's a lot of different words that you can use for zeros. You could use solutions or x-intercepts or roots. There's a lot of different things that all mean the same thing. Okay, but basically it would have solutions at positive a and positive b. Notice it's the opposite sign of what I had in the parentheses. Okay, if a polynomial has a factor that looks like this, x minus a squared, this is something that's called a bounce point or a double root. Okay, so basically it would have solutions at positive a and positive a. And the reason there's 2 is because it's squared. Okay, so let me show you what this would look like if I were to graph something like that, okay? So I'm going to give you an equation. Let's say I had y equals x plus 2 times x minus 1 times x minus 3 squared. Okay, so this one actually has 4 solutions. Okay, this one gives us a solution of -2. This one gives us a solution of +1. And this one actually gives us a solution of +3 and +3. And again, that's because of that squared right there. Okay, so wherever those solutions are, that's where the graph crosses the x-axis. Okay, so since I have, here, let me draw my graph here. Since I have a solution at -2, my graph is going to cross there at -2. I have a solution at +1, so it's going to cross there. And then I have 2 solutions at +3. Okay, so here's what this would look like. Okay, so it would go through and it would cross this point. It would come back down and cross this point. And then what's going to happen is it's going to bounce at this one. Okay, and there's a lot of different things that would actually, I might as well make this correct here. Since it's going down at the end, that would be a negative in front. Okay, but I also could have drawn it the other way. But it's going to cross at those three places, here, here, and then notice how it hits it, but it doesn't cross all the way through. It bounces back down. Okay, again, that's called a bounce point or a double root. Okay, so here's an example that deals with polynomials and zeros. Okay, in the xy plane, the graph of that quadratic, where b and c are constants, has x-intercepts at -2 and -6. Again, x-intercepts is another way to say solutions. Okay, so if the solution is -2, x plus 2 is the factor that gave us that solution. If there's a solution at -6, x plus 6 is the factor that gave us that solution. Okay, so what they want us to do is find b. b here is the number in front of x. So all I need to do here is multiply those two polynomials out, put it in standard form, and see what number is in front of x. Okay, so if I multiply this out, I'm just going to FOIL. Okay, so x squared plus 6x plus 2x plus 12. And then if I combine my like terms, I end up with x squared plus 8x plus 12. Okay, so since they want b is the number in front of x, that's going to be 8. Okay, so 8 is my solution. I put that in my grid in. There we go. Actually, should probably color it in a little bit better than that. Okay, that's it. You guys have a great day.